Hello my dear students, welcome back to NEET World. So today we will be discussing redox reactions as a part of our EAPCET 2026 preparation right now. So now in the last sessions we have seen the topics of first year as well as few topics of second year right now. So here again we will be discussing from the first year topic, that is redox reaction. Okay, I hope you are following our sessions for your upcoming EAPCET, JEE and NEET preparation. So these sessions are highly helpful for your all the exams like JEE, NEET and EAPCET exam. See, in this discussion I will be explaining about redox reaction, right? So now we will be having today one session, this is our first session, and continuously next 1 or 2 sessions will be there on this redox reaction. Okay, so now just look at the questions, like these are very basic from this redox reactions. You know guys, without knowing this reduction and oxidation process like redox reactions, we cannot do or we cannot make the chemical reactions properly from other chapters also. So it is a very basic and important chapter. Even if you are looking for the weightage of this topic, at least 1 or 2 questions, like 1 question for sure. And you know, in order to understand electrochemistry or any other part of chemistry, redox reaction is very important thing. Okay, so let me show you the questions that are asked in the JEE and NEET. First of all, see, these are basic level questions asked in JEE. See, oxidation numbers they are asking from these compounds. Again, see, oxidation number of nitrogen in these 4 compounds here, 4 compounds here. Okay, this is also JEE question, and here also JEE question right now. So these are very basic, and I will be showing you EAPCET questions as well as NEET questions from this particular topic. See, this is again JEE mains, all these questions you are going to solve this after this discussion. Okay, right. Let me explain everything with clear cut discussion on each and everything. See, these are NEET questions. See, I just wanted to tell you that yes, these basic questions are asked in any exam, whether you are a NEET, BPC or MPC student or biology student or preparing for medical or engineering, wherever it will be, in both exams it is very important. See, and the next it will be asked in even EAPCET also. Okay, we will be discussing EAPCET questions also. First of all, let us start our discussion on this redox reactions. Just tell me, just tell me what do we mean by redox reactions? Here the reactions which involves both oxidation and reduction process. What I am saying, reactions which involves both oxidation and reduction reactions. So what do we mean by reduction as well as oxidation? So this is what we need to know. See, reduction reactions in which both reduction as well as oxidation are taking place, then these reactions are considered as redox reactions. You know, where there are many applications on this redox reactions. For example, electrochemical cells that we are going to study in electrochemistry. Okay, so it means conversion of chemical energy into electrical energy by a redox reaction in the cell. In the electrochemical cell, a redox reaction takes place that generates electrical energy. What it will generate? Electrical energy. So from this redox reaction, chemical energy is now converting into electrical energy. So this is what happens in electrochemical cells. So this is one of the example you need to know. And where do you see this reduction like redox process like oxidation or reduction process in our daily life? See, we are seeing the rusting of iron. Okay, so if you place any metal surface like metal items in the like iron or any other metal items in the normal in the air, it is exposed to what? Moisture in the air right now. So when it is exposed to moisture, so what happens is slowly get rusted right now. So that is nothing but oxidation of iron is taking place. What is happening here? Oxidation of iron is taking place. It means here it is losing its electron. So I will tell you what do we mean by oxidation and reduction. So just listen here. See, there are 2 terms, one is oxidation, other one is a reduction. So what do we mean by oxidation? So you can define oxidation is nothing but addition of oxygen. What I am saying, addition of oxygen is called oxidation. For example, there is a magnesium metal, to that we are adding oxygen molecule. So what happens, it is forming magnesium oxide. So this is an oxidation reaction. Okay, addition of oxygen. Next, removal of hydrogen. What is the next reaction? Removal of hydrogen. It means from this sulfide S minus 2 is there, okay. So from this sulfide, hydrogen sulfide, we are removing these 2 hydrogens so that it is becoming sulfur. Right now here it is in zero oxidation state. So removal of hydrogens is also considered as oxidation, okay. So addition of oxygen or removal of hydrogens are considered as oxidations, okay. And along with this there is another way of discussing about oxidation, another way of defining. This is moderate definition whatever I am going to tell you now. If there is a metal M, now metal M is losing electrons and becoming its positive charge, okay. Here it is zero oxidation state converting into some plus oxidation state, okay. So now this many number of electrons, what is the charge here you are seeing? Positive N. So it means that many number of electrons are lost from this metal with zero oxidation state here. So it means here Ne, so E contains negative charge, therefore here N positive charge is there now, so here N negative charge will be there. So overall this side also be neutral, so overall charge will be neutral on both sides. So what do we getting from here? So when a metal loses, when a species loses, whether it may be metal, non-metal, anything, if the species losing its electron, it gets oxidized. That process is called oxidation. So we can say loss of electrons. What I am saying, loss of electrons or removal of electrons is also called as oxidation. See, Sn plus 2, tin plus 2 is there. Here tin plus 4 it is converted, okay, from plus 2 to plus 4. It means 2 electrons lost now. So you can say this is also an example of oxidation. What we are saying, removal of electrons are also an oxidation process, okay. And along with this, just look at here. So increase in positive charge, yes. How that positive charge is increasing? When a metal or any species losing electrons, it will be get positive charge. Right now that positive charge, increase in the positive charge is also called as oxidation. So plus 2 is converting into plus 4, this is also an example of oxidation. See here plus 2 is converting into plus 3, it means what you are seeing, it is also what is taking place here, electron is lost from this plus 2 ion, so that it is converted into plus 3, okay. So it means when electron is lost by the species, its positive charge, so there will be increase in the positive charge. So increase in positive charge is also called as oxidation, okay. So how that positive charge will be increased? By removal of electrons, okay, you can say in that way, okay. So increase in oxidation number, see here you are seeing here plus 2 and here it is plus 4. So what happened during this reaction? Here only 2 chlorines are attached, here 4 chlorines are attached, okay. So I will tell you what is happening here, but what you are saying, increase in oxidation number. So how to calculate oxidation number, we need to learn it, okay. We will be discussing about that. So increase in oxidation number is also called as oxidation, like undergoing oxidation, that is oxidation process only, okay. I hope all these oxidation reaction examples are clear without having any confusion, okay. So if you understand this basic definition, yes, there are a lot of questions asked in NEET, JEE and EAPCET, we are going to solve them. So if you clear with this, yes, definitely you are going to attempt them without having any confusion, okay. Now look at this, this is about reduction. See, their addition of oxygen is called oxidation now, and here it will be opposite, there is addition of oxygen, here removal of oxygen. So removal of oxygen is called reduction. What I am saying, removal of oxygen is called reduction. For example, here CuO, copper oxide is there, converting into copper metal, okay. So copper converting into copper metal now. So what is happening here, oxide is converting into copper metal only. So oxygen is removed now, so it means copper is undergoing here, copper oxide, like copper plus 2 here. I will tell you how to calculate oxidation state. So this copper oxide is converting into copper, it means this is an example of reduction. What I am saying, this is an example of reduction. And if you observe within the reaction, see copper, here copper is there, carbon is there, so carbon is taking this oxygen from this copper oxide, converting into carbon monoxide. So what is happening, you are adding that oxygen atom to the carbon now, so you can say carbon is undergoing oxidation. What you can say, this is undergoing oxidation. Like this you need to identify which is a reduction process, which is oxidation process during a chemical reaction, okay. During a chemical reaction, so you need to identify in that way, okay. Right. Let me explain you few more things. Yeah, those who are in the live session, please click on the follow button and like button if you really clear with the discussion. Yeah. So now look at here what I am explaining. One more point here, there you are saying removal of hydrogen now. So here it is what? Addition of hydrogen is called reduction. What is that? Addition of hydrogen is called reduction. It means opposite of that reaction, you can say. See, to this sulfur we are adding hydrogen, so it is becoming H2S. So addition of hydrogen to this sulfur is considered as reduction process. Okay, right. Next, one more thing you can say, decrease in the positive charge. Here increase in the positive charge is called oxidation, decrease in the positive charge is called reduction. But if you observe one common thing here, so whenever you remove electron, its positive charge increases. See, from +2 to +3 is happening here. So what is the reason for this? Because we are removing one electron from iron, from +2 ion we are removing one electron, that's why it is becoming +3. So increase in positive charge is possible by removal of electron. Okay, so that removal of electron is nothing but oxidation now. So that results to increase in the positive charge. Okay, now here addition of electron will results in the decrease in positive charge. See here, +3 ion is there, opposite of this reaction I am saying. So +3 ion is there, to that we are adding an electron, so it is becoming +2. It means by addition of this electron to this ion, what is happening? Charge is reduced now, so decrease in positive charge is called reduction. Number is reducing now, so you can say reduction. Okay, reduction in number, that is what? Reduction. Okay, addition of electron, see that why it is happening? By the addition of this electron only this process is taking place now, so we can say addition of electron results for reduction process. Okay, remember this. And one more thing here, if you observe, MnO4 minus is there, so here oxidation state is +7, now here it is in +2, so it means +7 to +2 conversion, we are adding 5 electrons. How many electrons are added? 5 electrons. So addition of electrons is nothing but oxidation only. And if you want to say in one more manner, see here oxygens are 4, but there is no oxygens product side now, so removal of oxygen is what? Reduction only now, removal of oxygen is reduction. So this is an example of reduction. Okay, right. These are the examples, like increase in oxidation number is called oxidation, decrease in oxidation number is called reduction. Okay, so these are some examples that you need to know, okay, in order to understand this concept. Okay, and along with this you need to know how to calculate oxidation number. So first of all, what do we mean by oxidation number? Okay, what do we mean by oxidation number here? So just tell me, what do we mean by oxidation number? So a oxidation number is a arbitrary charge, it is an imaginary charge present on the atom in a compound. For example, I am giving you CO2 molecule. What I am giving you? CO2 molecule. Now I will be asking, what is the oxidation state of this carbon? Okay, this is how the simple question will be asked. So it is very easy, you can answer all these things. First of all, understand the definition of oxidation number here. See, it is an imaginary charge developed over the atom of an element when it goes from its elemental free state to combined state in a molecule. Okay, so it is an imaginary charge developed over the atom when an atom is going to form a particular compound, when it is in its combined state like this. Okay, this is a carbon free elemental state, graphite you can say, combining with oxygen to form carbon dioxide now. So now what is the oxidation state of this carbon in this molecule? Okay, this is how they will ask. Okay, very easy. I will tell you I will show you the questions also, but listen to me for a few more minutes. See here, how do we calculate oxidation state of carbon? This is a question they will ask. See, it is based on assumptions that the complete transfer of electron takes place from a less electronegative atom to a more electronegative atom. It means here carbon dioxide you are seeing right now. So carbon dioxide will be like this. Okay, now depending upon the electronegativities of central atom and the surrounding atom, these oxidation states are given to the elements. Okay, so now each bond contains 2 electrons. How many electrons are there in each bond? 2 electrons. So these 2 electrons in a bond will be taken by one species, only one element. When we are calculating oxidation state, you need to consider, for example, this is a bond right now. So the bonded electrons are taken by only one element which is more electronegative, so that element will take that bonded electrons. So between carbon and oxygen, which is more electronegative? Oxygen right now. So it means the bonded electrons are taken towards oxygen only. So for example, let me write one simple example here. So HF I am writing. So hydrogen fluoride is a molecule, covalent molecule here. Okay, bond, we have covalent bond between them, polar covalent bond is there. So now this bond will polarizes, or this bond will be taken towards more electronegative atom. Which is more electronegative out of these two? Fluorine is more electronegative now. So you should write this complete bonded electrons on fluorine as F minus, fluoride ion. So if these two electrons are taken by fluorine, it is becoming F minus. So then what about the charge on hydrogen? It should be plus 1. So hydrogen with plus 1, fluorine with minus 1. So what are the oxidation states of hydrogen and fluorine here? For hydrogen it will be plus 1 for hydrogen, okay, like H plus you should write, and for fluorine you should write it as minus 1, that is F minus, like that. Okay, hope the discussion is clear. Is this clear or not? If the discussion is clear, just click on the like button, and if you have any confusions, feel free to mention in the chat box. Now look at here what I am saying for the carbon dioxide. See the bonded electrons here, how many bonded electrons are there? So these are 2 bonds now. Which is more electronegative? Tell me, carbon or oxygen? See, oxygen is more electronegative. So the bond here, how many bonds are there? 2 bonds now. So both bonded electrons are taken towards oxygen only. So for one bond it will be minus 1 charge on more electronegative atom and plus 1 charge on less electronegative atom, because bonded electrons are taken by oxygen now. So that's why it is having minus 1. Carbon is losing electrons now, so that's why it is plus 1. Like that, how many bonds are there here? So between this oxygen and carbon, 2 bonds are there. So you can write minus 1 with each respect to each bond, and here plus 1 with respect to these 2 bonds. Okay, and similarly this side, so this bond is taken by oxygen minus 1 and carbon plus 1. Same here also minus 1, here plus 1. So totally how many positive charges you are seeing on the carbon here? Just see, there are 4 bonds, all 4 bonds are taken by oxygen atoms only. It means carbon will be now in plus 4 oxidation state. See, plus 1, plus 1, plus 1, plus 1. So total sum will be plus 4. Okay. So now what is the oxidation state of carbon in carbon dioxide? It will be plus 4. Now what about oxygens here? Each oxygen will be now, see, minus 1 and minus 1. So it will be minus 2 forms. Okay. So this is how you need to give the oxidation number for each element in a given compound. Okay. Hope the discussion is clear. Right. The thing is clear means just click on the like button, guys, and we will be discussing few more things here. Just listen here. I am writing sodium oxide like Na2O, Li2O, like this I am mentioning, and the next I am writing Na2O, Na2O2. Okay, right. The next I am writing K2O2, and the next I am writing KO2, like this I am writing. Okay, so now from this what you are understanding? See, there is one alkali metal. See, if you observe in all these examples, lithium, sodium, potassium, rubidium, all these are what? First group elements, first A elements. Now for first A elements, whenever they are combining with any other element, what I am saying, whenever they are combining with any other elements, so these alkali metals will be have positive charge, plus 1 charge. What is the charge on them? Plus 1 charge. All alkali metals will have plus 1 charge in their combined state. Whenever they are attaching with some other element, definitely these are highly more electronegative elements. That's why they will be always in unipositive charge. With what charge? Plus 1 charge. Okay, and similar to these second A group elements are there. Now what are second A group elements? Like beryllium, magnesium, okay, sorry, magnesium and calcium, these are there now. So these are with the plus 2 oxidation state. What is the oxidation state? Plus 2 oxidation state when they combined with any other species, I am saying, because these are metals, now, alkali metals, alkaline earth metals. Metals are electropositive right now, and these alkali metals are highly electropositive. So due to that reason, they always have plus 1 charge, and these fellows always have plus 2 charge in their combined state. Okay, remember these 2 points to understand further. Okay, now look at here, Na2O we are saying. So each sodium, how many sodiums are there? 2 sodiums are there. So plus 1, and oxygen will be X. I want to find the oxidation state of oxygen. Overall molecule is neutral now, so that is what? 0. Okay, so X will be now minus 2. What is the oxidation state of oxygen here? Minus 2. Similarly, if you find here, see if you find here, here also you will get -2, and for each lithium it will be +1. Okay, now what about here? So each sodium will be +1, like that how many are there? 2 sodiums are there, +1 and +1. Now what about oxygen? So oxygen will be O2, -2 charge will be there. Okay, so it means 2 molecules, 2 oxygen atoms, you have -2 charge. So it means one oxygen atom is how much? Look at here, for one oxygen atom only -2 charge is there. Here for 2 oxygen atoms it is -2. It means for one oxygen atom it will be -1 right now. So it will be O2 in this it will be -1 charge. Okay, oxygen atom will be in -1 charge. Okay, now what about these? So here K plus 1 now, so it means your O2 molecule itself is having -1. So complete O2 molecule is having only -1 charge. So for one oxygen atom out of these two, one oxygen atom will be -1/2 will be the charge. Okay, now there are the oxygen atoms with different oxidation states if you observe here. So here it is in -2 charge, here it is in -1 charge, here it is in -1/2 charge right now. So I am saying with respect to each oxygen atom. So oxygen atom, whenever it is in -2 oxidation state, you should call it as oxide. What you should call? Oxide. Whenever oxygen atom is in -1 oxidation state, you should call it as peroxide. How do you call? Peroxide. Whenever oxygen atom is in -1/2 oxidation state, you should call it as superoxide. What you should call? Superoxide. So these are the names to be remembered for answering the questions. Because why I am explaining this in detail? Because there is a question related to oxide, superoxides, peroxide from JEE Main 2021. Okay, now you are going to solve that question after few more minutes. Okay, now look at here. Always remember, always fluorine, if it is fluorine atom is combining with any other element, fluorine will be with -1 oxidation state. What I am saying, when fluorine atom is combined with any other element, it will be having -1 oxidation state. When fluorine combined with itself like F2, the oxidation state of fluorine will be 0. What I am saying, oxidation state of fluorine will be 0 only in the case when fluorine combined with itself, like to formation of fluorine molecule. Okay, right. If it is forming fluoride ion F minus, so here oxidation state will be -1. Okay, so when -1 is possible, in all other combined states for fluorine it will be -1, except when itself combines to form F2 molecule. Okay, in this case it will be 0, in all other cases it will be -1 oxidation state only. So give some examples. Yes, you can write. See, HOF I am writing, or HOF I am writing, HF I am writing, okay, or I am writing ClF3 I am writing. See, why? You should get a doubt, sir, why it is minus all the time? Because fluorine is most electronegative element in the periodic table, most electronegative element in the periodic table. So due to its high electronegativity, always fluorine will be in -1 oxidation state when it is combined with any other elements except with itself. Okay, right. Then next here similar to this, oxygen atom you should remember. Okay, so oxygen is a second most electronegative element. What I am saying, second most electronegative element in periodic table. So due to this reason, oxygen will be mostly, it will be -2 form. So when it is in -2 form, you should say oxide. Just now we discussed, when it is in -1 oxidation state for each atom, then you should say peroxide. What is that? Peroxide. Okay, what is the example here? H2O2, like that. Okay, and the next, if oxygen is in -1/2 oxidation state, you should call it as superoxide. What I am saying, superoxide. Example is KO2, potassium superoxide. Okay, so these are the states. Now, does all the times oxygen will be negative charge? No. Okay, there are few cases in which oxygen can also be in positive oxidation state or in zero oxidation state. See, remember, whenever an element is combining with itself, okay, then oxidation state of that element will be 0 in that molecule. For example, oxygen atoms are combining with themselves and forming O2 molecule. See, there is no electronegativity difference between two oxygen atoms now, therefore this will be 0, this will be also with 0 oxidation states. Okay, so this is how you need to give the oxidation states for the elements. Now look at here what I am saying. Water molecule I am writing, which is more electronegative? Oxygen atom is more electronegative, because I am saying second most electronegative in the periodic. Okay, and what is first most here? Fluorine. Okay, therefore what happens here? So oxygen will be -2 charge, 2 hydrogens are there, each hydrogen with +1 charge. Okay, sir, how do you get exactly like this? Just write its structure by looking at its structure. You can say which is more electronegative? Oxygen. So bonded electrons are taken by oxygen, that creates -1 charge with respect to this bond, and hydrogen +1 charge with respect to the bond. Okay, same story here also, -1 from this side and +1 here. So total negative charge on oxygen will be -2, and total positive charge on hydrogen is +1. Like that, 2 hydrogens are there. Like this you should say. Okay, so you can say H2O is an example of oxide of oxygen. What is that? Oxide form of oxygen. Okay, now what about this H2O2? This is peroxide form of oxygen. So if it is KO2, this is superoxide form of oxygen, you should say. Okay, up to here it is clear, no? Now tell me, I am writing a compound here, HClO4 I am writing. What is the oxidation state of chlorine here? You need to give the answer. So what we know here, oxygen is divalent. What is the electronic configuration of oxygen? So you are writing 1s2, 2s2, 2p4. 2s2, 2p4 is a valency electronic configuration. See, there are 6 electrons. If we give 2 more electrons, what I am saying, if I give 2 more electrons, it becomes 8 electrons in a valency right now. So whenever there is 8 electrons in the valency, that species become stabilized. Okay, this is oxygen atom. By adding 2 more electrons, it becomes oxide ion, like -2. So in oxide ion form, it will be having 8 electrons. So why the species are showing chemical reactions? To attain stability. How this stability is attained? For an element, when it is acquiring most stable electronic configuration. For example, here oxygen is 2s2, 2p4 now. By gaining 2 more electrons, it will get nearest noble gas configuration. What is the nearest noble gas? Will be oxygen, which is atomic number 8. So the nearest noble gas is neon, which is atomic number 10. So it means how many electrons are required here? So 2 more electrons are required because it has 6. If I give 2 more electrons, it will be stabilized. That's why oxygen, to gain inert gas configuration, always have tendency to gain 2 more electrons. So whenever oxygen is combining with any other elements which are less electronegative than the oxygen, always oxygen tries to be with negative oxidation state only. With what oxidation state I am saying? Negative oxidation states, so that it will get nearest noble gas configuration. Okay, so this is the main reason for existing in minus 1 or -2 oxidation state. So in this case, chlorine oxidation state I am asking, what is the oxidation state of chlorine? So consider it as X. Now hydrogen is less electronegative than all of these things now. So write +1 for hydrogen. How many hydrogens are there? 1. So chlorine I don't know, let us take it as X. So for oxygen, 4 oxygen atoms are there, each oxygen will be -2 charge, overall it will be 0, because overall molecule is neutral, that's why it is equalized to 0. So X will be now how much? -8 plus 1, that is -7. So -7 send that side, will become +7. So +7 is the oxidation state of this chlorine in the molecule. Hope you got how to calculate this oxidation state. Okay, now what I told you, oxygens in very rare cases, there are only 2 molecules in which oxygen will be with positive oxidation state. So here if you observe this one, O2F2 and OF2. Okay, so when you see H2O, OH2, so when you see this OH2, oxygen is in -2 oxidation state, because oxygen is more electronegative, that's why the bonded electrons are taken by oxygen, so it is creating +2 H plus ions and 1 oxide ion. Okay, so here also it is same in H2O, but when it comes to OF2, so which is negative here, because more electronegativity of fluorine, so fluorine will be in fluoride forms. Okay, and oxygen will be with a positive charge, like F, here F. Okay, the bonded electrons are taken by oxygen or fluorine only, so -1 charge on fluorine and plus 1 charge on oxygen. Therefore, oxygen will be in cationic form in this case. Okay, here also taken by fluorine. So, you can write minus 1 on fluorine, plus 1 on oxygen. Therefore, oxygen is in plus 2 oxidation state. In this case, you need to remember this kind of example. In which of the following oxygen will be in positive oxidation state? They will ask like this. So, what to do? Just identify the given molecules and assign their oxidation states. That's it. Okay. Hope this discussion is clear. Now, what about oxidation state of oxygen in the second compound? Tell me. Anyone in the chat box can answer me. What is the oxidation state of oxygen in the given molecule? Okay. Now, what about oxidation state of oxygen in this? How do you write this? So, look at this, oxygen are there. So, you need to know oxidation state of oxygens here. So, oxygen you consider X and fluorines are how many? 2 are there. So, minus 1 each, overall will be 0, neutral molecule. So, 2X will be plus 2. So, oxygen will be in plus 1 oxidation state. So, here oxygen is in plus 1 oxidation state. Okay. So, now like this, in the similar manner I will be giving you few more compounds to calculate the oxidation states. Okay. So, just tell me what are the oxidation states of sulfur in this molecule. Just tell me what is the oxidation state of sulfur in the molecule. Plus 6. How do you calculate that? So, consider this as X plus 4 oxygens, each one minus 2, overall charge is minus 2, that will be plus 6. Okay. Now, let me give you few questions from JEE. Yeah, tell me for this. What are the oxidation states of potassium in this case? From the discussion only you can answer that without having any confusions. Not oxygen, what they are asking, be conscious. They are asking for potassium, right? So, always alkali metals, whenever they are combined with some species, always they will be unipositive with plus 1 oxidation state, right now. So, here potassium will be plus 1, here also plus 1, here also plus 1. So, whatever may be the compound it is forming, if there is alkali metal, that will be in the combined state, it will be plus 1 oxidation state. Okay. Because alkali metals, they won't combine with themselves. Now, there is no, you cannot say that like 0 or something like that, but when it is in elemental form, it will be 0 like K. Okay. But whenever it is combining with some X compound, it will be always with a plus 1 charge. Okay. So, now based on that, what is the answer for this? Fourth option. Now, next tell me for this nitrogens in this compound, 4 compounds. Oxidation state of nitrogen in these compounds are in the order. Which order is correct here? Find here. So, one oxygen is there, we know oxygen is bivalent or divalent. So, it will be plus 2 for nitrogen because oxygen is more electronegative. Then here it is plus 4 for nitrogen and here it is plus 1 for nitrogen because oxygen is minus 2 and here plus 5 for nitrogen. So, based on that NO3 minus nitrate, nitronium ion like nitrogen dioxide, nitric oxide, nitrous oxide N2. Okay, that's it. So, second option will be perfectly correct, right? Next, tell me for this what they are saying. Identify the process in which change in oxidation state is 5. What What are the oxidation states here? You just tell me for oxalate ion here. These are very important because you are going to do some balancing of redox reactions or redox chemical reactions, law of equivalence application based questions. All these things we will be seeing there again. So tell me, so C2O4 2 minus means what is the oxidation state of carbon in this case? See here, how do you calculate that? 2x you take for carbon, the next x value you need to find now. 4 into each oxygen will be minus 2, overall charge is minus 2. So minus 8 send that side, it becomes minus 2 plus 8, that is plus 6. So x will be how much? Plus 3. So oxidation state here is in plus 3 converting into plus 4 right now. So it means how many electrons here change? What is the oxidation state change here? Only 1. What is oxidation state change? 1. And similarly you calculate for this one. MnO4 minus permanganate ion converting into Mn plus 2. Five. So what is our answer for the question? Second option, because permanganate ion MnO4 minus charge is there, so manganese in plus 7 oxidation state converting into Mn plus 2. Okay, so how much change in oxidation number? 7 to 2 means 5. Okay, that's it. Next, what about this dichromate to chromium plus 3? What is the change in oxidation number? So here it is plus 6 oxidation state for each chromium converting into plus 3. So change here is 3 only. So here also plus 6 now converting into plus 3. Here also change is 3. So what is our suitable answer? Second option. Next, tell me for this, what are the oxidation states of phosphorus in this given compounds? Tell me, what is your answer for the question? Yes, they are mentioned phosphorus. So now what to do? So 7 oxygens are there here, so minus 14. So it means you consider 4 hydrogens are there, each one plus 1. So no need pen paper also, you can do on your like with fingers, like just 2x. So 7 into minus 2 equals to 0. So it will be 14, minus 14 here, this is plus 4, means minus 10 it becomes. Send that side, 2x becomes plus 10. Okay, so x will be 5. Okay, so here 5, 5. So remaining 2 options you can remove. Similarly, you tell me for this. So 5 oxygens are there means minus 10. Hydrogens are plus 4 means 6 is there. So 6 by 2, 3. So what is the oxidation state for the central one here? 3. So 5, 3. And the last one if you try, here minus 12. Here you can remove 4. It means how much? 8. So 8 by 2 means 4. Okay, so 5, 3, 4, that's it. Fourth option will be your answer. Okay, right. Next. Just listen this again. So that is about oxidation state calculations. Again we will be doing few more questions after the discussion. Now see, whenever their oxidation state is equals to maximum oxidation state, what I am saying? So how can we calculate that maximum oxidation state for an element? For example, I am giving you nitrogen. What is the maximum oxidation state possible for nitrogen, they will ask. How can you answer this? Not plus 3, it is plus 5. Maximum is plus 5 because its valence electronic configuration you write 2s2, 2p3. So the maximum oxidation state of an element will be equals to number of electrons in the valency shell. What we are saying? Number of valency electrons. For nitrogen, how many valency electrons are there? 5. Right now, so you can remove all these 5, so it becomes plus 5 maximum, like this. Okay, for an element, how do you find maximum oxidation state possibility? By looking at its valency electrons. Okay, for example, manganese I am saying. Tell me, what is the maximum oxidation state possible for manganese? No, it is plus 7. Why it is plus 7? Because it has atomic number 25, which means 3d5, 4s2 is the valence electronic configuration for this manganese. Okay, inside this you have argon configuration. Okay, 18, after 18, 19, 20, 25. Okay, it means valence electrons are how many? 7. So all the 7 can be removed, therefore manganese can show oxidation state maximum of plus 7. Beyond that it is not possible for manganese. Why? Because there is no like extra electrons other than this right now. That's it. Next one is, what about minimum oxidation state? This will be electrons in the valency shell minus 8. For example, nitrogen only you take, how many valence electrons we taken? Valence electrons are 5. So 5 minus 8. 8, why we are taking 8? Because it's octet number, right? So 5 minus 8. So how much it is? Minus 3. So what is the minimum oxidation state possible for nitrogen? Minus 3. Maximum oxidation state possible for nitrogen is plus 5. These things. Okay. And similarly, if I ask for sulfur, okay, so sulfur has valence electronic configuration as 16th group now, like oxygen family, NS2, NP4. So how many? 6 electrons are there. So sulfur 6 electrons are there, means a minimum oxidation state is possible is how much? 6 minus 8, so minus 2. And what is the maximum is possible? All the 6 electrons can be lost and can show plus 6. Okay, so now what is the example compound for plus 6? You can say SF6. What is that? SF6 is the example. And what about minus 2 oxidation state containing compound? Best example is hydrogen sulfide, H2S. Okay, now what about NH3 minus example compound here? So ammonia, here minus 3, nitrogen is in minus 3 oxidation state. What about NF5 here? What is a NF5 is not possible. So what is a possible plus 5 oxidation state compound? You can take N2O5. What is it? N2O5. Now tell me, is it possible to make a NF5 compound? Is it possible to make NF5 type of compound? Why not?
Because electronegativity of chlorine distracts.
No, not that is not that reason. But see, how many orbitals are there with the nitrogen? Like you are writing 1s2, 2s2, 2p3 right now. So it means there is 2s orbital and there is 2p orbital. Okay, so fill these electrons 1, 2, 3, 4, 5. Okay, valence electrons. Okay, so now how many orbitals we have? Valency orbitals are 4. Okay, so it means an atom containing 4 valency orbital can make only maximum of 4 bonds. How many bonds it is? But here how many fluorines are there here? 5. So that 5th bond cannot be made with that fluorine. So it means NF5 cannot exist. Only NF3 can be exist. NF3 is possible but not NF5. Okay, that's it. This is the reason. Okay, so minimum oxidation state will be valency electrons minus 8. Maximum oxidation state will be equals to number of valency electrons present in that species. That's it. Okay, then next. Now for an element, if the oxidation state is equals to maximum oxidation state, what we are saying? For an element, oxidation state is equals to maximum oxidation state. It will acting as a strong oxidizing agent. How it will be? Strong oxidizing agent. Okay, for an element, for an element, if oxidation state is equals to minimum oxidation state, it will be acting as a reducing agent. Just remember, if it is equals to maximum oxidation state, act as a oxidizing agent. For example, KMnO4 we have. You are saying KMnO4 is an example of oxidizing agent. What we are saying, this is an example of oxidizing agent. Why? Because here manganese is in maximum oxidation state, +7. That's why it is acting only as oxidizing agent, not as reducing agent. Okay, it can have only ability to show oxidizing agent property. Okay, now what about reducing agent means? Here the oxidation state, whenever it is in minimum oxidation state, for example fluoride ion, okay, so it will be acting as not fluoride, reducing agent, no, reduces others, oxidizes itself. Okay, so you take any species like F-2 like this. If you take, what is this? So the minimum oxidation state for sulfur, what is the minimum? What is the minimum oxidation state possible? -2. So here it is in -2. So it can only act as reducing agent, not as oxidizing agent. But whenever the oxidation state is intermediate, now you need to know what exactly oxidizing and reducing agent. I will define what exactly. But before that, if the oxidation state is in intermediate, it means in between maximum and minimum, that has ability to show both oxidizing agent nature as well as reducing agent. Okay, so now I will tell you here. When I am saying an species is undergoing oxidation, see for example I am writing this well known example like copper +2 plus zinc is there. So this is converting into copper plus Zn+2. Now what is happening here, just tell me. Zn is converting into oxidizer form. Okay, so what is this process called? Loss of electrons is oxidation. Okay, and what about this process? Reduction. So now what is happening here? So this species gaining 2 electron from zinc. Okay, so now this is a species responsible for a reduction of this species right now. So you can call zinc as a reducing agent. What I am saying, zinc as reducing agent. I am not saying Zn+2, I am saying zinc as a reducing agent. Okay, now reducing agent is a species which reduces others but oxidizes itself. Okay, this is what the concept of reducing agent and oxidizing agent. Okay, so now look at here what I am saying. Reducing agent is a species that oxidizes which reduces others and oxidizes itself. Now look at this compound here, copper +2 is responsible for oxidation of zinc right now, because zinc converting into Zn+2. It means what you can say, copper +2 here acting as an oxidizing agent. Why we can say it is oxidizing agent? It is oxidizing zinc element to its +2 oxidation state. So copper is responsible for oxidation of zinc. Okay, so you can say copper +2 is responsible now, so you can say it is an oxidizing agent. So an oxidizing agent oxidizes others and reduces itself. Okay, so these are the 2 points to be remembered. Okay, now see, whenever I am saying oxidizing agent, what it should do? Oxidizes others, itself. Now tell me, is it possible for KMnO4 to act as a reducing agent or not? See here, reducing agent means what? It should reduces others, oxidize itself. See, if a species is already in its maximum oxidation state, how it will undergo further oxidation? Not possible now. So that's why KMnO4 cannot act as a reducing agent, but it can act as a oxidizing agent. Why? Because now if I say it is an oxidizing agent, if I say KMnO4 is an oxidizing agent, what it will do? Oxidizes others, reduces itself. Okay, here it is in +7 oxidation state. For example, here you have something like Fe+3 ion is there. Now what happens? Now this manganese converts iron +3 to +2. It means it is reducing others. It is reducing others means it should oxidize itself. Is it possible for manganese? No, because already it is in maximum. So but if I take in this manner, +2 here, +3 here, just consider here. Now what is happening here? Oxidation. Okay, it is undergoing oxidation. How it is undergoing oxidation? See, this is a species oxidizing Fe+T to +3. It means this species should undergo reduction. So reduction is possible for manganese +7 now, because here already maximum oxidation state, so it can reduces itself either into +4 form, like lower oxidation state. Lower oxidation states means +6, it can be like it can be a +6 one, or it can be a +4 one, or it can be a +2 one. Like that it can reduces itself and oxidizes others. So that's why we are saying KMnO4 can only be oxidizing agent, cannot be a reducing agent. Okay, similar story applicable for K2Cr2O7. Okay, K2Cr2O7. What is the oxidation state of chromium? Here it is, tell me, based on the discussion. +6. So whenever it is in +6 oxidation state, this is the maximum oxidation state possible for chromium. So it cannot be a reducing agent, it cannot be a reducing agent, oxidizing agent only. Okay, that's it. This is the discussion of the thing. Next, this discussion is clear. So all these species, if you observe, all of them are in their maximum oxidation state. What I am saying, all of these are examples of oxidizing agents, and if you verify them clearly, we discussed about these two things, and here nitric acid is +5, sulfuric acid is +6, fluorine, maximum oxidation state possible for fluorine is 0 only. It cannot be positive for fluorine atom. Okay, fluorine. Okay, that's why these are the maximum oxidation state possible for these elements. So they can be only oxidizing agents, they cannot be reducing agents. Okay, right. So now if you see this, this thing here, potassium iodide, this is a minimum oxidation state. Okay, so this can be the examples of reducing agents. Okay, now this, if you see this species like H2O2 I am writing. Okay, so here oxygen is in -1, oxygen is in -1 oxidation state. What is the minimum oxidation state possible for oxygen? It can be -2 also. The minimum oxidation state possible is -2, and maximum it can go to 0, +1, it can be showing +2. Okay, mostly these are the possible maximum oxidation state for oxygen. Okay, so now what happens is, in this case is, so here oxygen will undergo self oxidation, self reduction. It means it will be giving you H2O molecule plus O2 molecule. So what is happening here, -1 is converting into -2, and here 0. So what is this process called? -1 number decreased now, reduced now, so you can say reduction. What is this? Reduction. Now what about this process from here to here? See, minus is converting into 0, it means increasing number, so you can say oxidation. So one more thing here you can see, the same element undergoing reduction and oxidation. So this process is called what? Disproportionation reaction. So now you can make one more statement also. A disproportionation reaction is possible for an element if it is in intermediate oxidation state, but not in its minimum oxidation state, not in its higher oxidation state. Okay, a species will undergo disproportionation reaction whenever it is in its intermediate oxidation state only, but if it is in its maximum or in its minimum or lowest state, it is not possible to undergo disproportionation reaction. That is what you need to remember here. Okay, right. The next here, yeah, these points already whatever, see these points are just to make you clear and to take the notes from these, whatever we discussed, all the points are included over here. Next, disproportionation means what we discussed, the species, same element will undergo reduction. Okay, let us see some questions on this. See, these are some examples for a disproportionation reaction. See, what is the first example that we discussed? H2O2 is converting into H2O plus O2. Okay, so here halogen is there, X2 in dilute form. See, these are the questions directly asked in your NEET and even JEE advance also. We have a question from this one. In the last year they have a question from this case. Okay, so what they are saying, X2 with dilute base, if it is dilute NaOH like this, you are going to get X minus and XO minus. It means if I take chlorine plus NaOH, dilute NaOH, so this gives chloride ion, one chloride ion and one hypochlorite ion. So OCl minus, that is here Na is there, NaOCl, okay, NaOCl type of product is produced, okay. But if I take this NaOH, here it is dilute, but if I take concentrated NaOH, what we are taking here, NaOH, but this is concentrated. So now what happens is chloride ion formed as it is, but here it is chlorate ion. What it is forming? Chlorate ion, ClO3 minus, okay, like XO3 minus means ClO3 minus. So you can say NaClO3 like this, okay. Remember this products formed here in the first case hypochlorous, in the second case it is chlorate. What is that? Chlorate ion, okay. These two reactions are very important. And if you observe this, F2 does not undergo disproportionation reactions. Why it won't undergo? Because it is the most electronegative element. Since it is the most electronegative element, what is the maximum oxidation state possible for fluorine? 0. So it cannot be positive. It cannot be positive. No, that's why it cannot undergo disproportionation. It will stays in this way only, either in or in negative like F minus form, but not any of the other possible oxidation state for this. Only these two oxidation state, -1, 0 are the two possible oxidation states for fluorine. If you see, if you treat this fluorine with dilute NaOH, what we are getting here? F minus, okay, that is nothing but NaF plus OF2 you got. What you got? OF2, okay. OF2 means what is the oxidation state of fluorine? -1 here also -1, here also -1. It means 0 is converting into -1 means fluorine is undergoing what? Fluorine 0 is converting into minus oxidation state means what? Reduction, okay, right, remember. Now what about oxygen? -2 is converting into +2, -2 is converting into +2, it means it is an oxidation. So oxygen is undergoing oxidation, fluorine is undergoing reduction. So this is an example of redox reaction. This is an example of redox reaction, but not a disproportionation reaction. Remember that, okay. So now if same fluorine, if it is treated with concentrated NaOH, with what? Concentrated NaOH, so that we will get F minus, same like this, F minus, here it is OF2, here it is O2, okay. So depending upon what type of species like reagent we are taking and concentration of reagent, product formed also different. Here it is OF2, here it is O2, okay. These are the two things you need to remember, okay. So Cn twice with OH minus gives Cn minus and OCn minus, okay. Next P4, okay. So P4 is a phosphorus, okay. So phosphorus will give phosphine and H2PO2 minus. So what is the oxidation state of this phosphorus in this case? +1, okay, and here it is -3, okay. What is the oxidation state? +1 and -3, okay. Next, what about this one? Here it is 0 converting into -2. See, if you observe in this disproportionation reaction, element will be forming the compound with the minimum oxidation state, one possible minimum oxidation state. What is the minimum oxidation state for phosphorus? -3. So that's why here -3 form, and then another one here it is +1 oxidation. And here what is the minimum oxidation state possible for sulfur? It is -2. So we got a -2 oxidized product, I mean oxidation state containing product. And the next like S2O3, thiosulfite is formed. Here the oxidation state, if you see, what will be the oxidation state you will get? Just tell me. Find it for one sulfur atom in. See how it is, S2O3 2 minus. This is also called as hypo. What I am saying, Na2S2O3 is considered as hypo, okay. Its oxidation state is very important thing here, okay. So if you see 3 oxygens are there, so you can take 2x plus 3 minus 2 each oxygen equals to -2 for the overall charge. So x will be -2 plus 6, so this will be +4, that means x will be how much? X will be +2, okay. So this is how you need to do the calculation for oxidation states here, +2. So one is +2, here -2, remember this thing, okay. So here MnO4 2 minus is there, so it means oxidation state is +6. See, if MnO4 is in -1 charge here, it will not undergo oxidation or it will not undergo oxidation, okay, because already it is in maximum oxidation state. But here it is in which oxidation state? 6. If it is 7, it won't undergo oxidation. but 6 means it can undergo to plus 7, na? Yes, oxidation is possible as well as reduction is also possible. So MnO4 2 minus can show disproportionation reaction but not MnO4 minus. Okay, these are the things you should remember for this disproportionation reaction example. Next, what about comproportionation means? See, the nitrogen in the given compound has here -3 oxidation state, here it is +3 oxidation state. What are the oxidation states? -3 and +3. Now these two oxidation states are giving you single oxidation state of 0. So it means what you can say this process as, it is something like reverse of disproportionation. Now yes, you can call it as comproportionation reaction. The reverse of disproportionation can be considered as comproportionation reaction. Okay, so you can say comproportionation reactions are reverse of disproportionation reactions. Okay, so an element with two different oxidation state is forming a single oxidation state product, then that particular reaction is considered as comproportionation reaction. Okay, so reverse of this process is what? Disproportionation. Okay, remember this. Okay, right, because reverse means here 0 is converting into -3, reduced form, oxidized form. Now that's why reverse is called disproportionation and this forward is called comproportionation. Okay, remember these two things. Okay, the remaining questions related to this disproportionation and all we will be solving in the upcoming session, but just see these NEET questions guys. Those who are in the live session can answer me, or those who are watching this after recording version also, you can answer me your questions for this in the chat box. So if you want me to verify, just mention the time slot and you can give your answer, so that I will definitely look into it and I will tell you whether it is correct or not. Just try these questions. All these questions whatever I am showing is for you to practice. Okay, so just practice them and mention your answer in the next in this chat box. Okay, so right, so the remaining things we will be discussing in the upcoming session. So stay tuned with us, and if you are new to this channel, click on the follow button and you can share with your friends. So thank you for watching. Stay connected. Thank you.